Hey guys, today we're going to talk about ionic bonding, and objectives for today is to discuss the properties of ions regarding noble gas configuration and what is the octet rule. We're also going to understand situations where ionic bonds will occur, and then you'll understand how to draw and show different ionic bonds. So what is noble gas configuration? If you look at group 18 on your periodic table, those are called your noble gases. And in your noble gases, the outermost energy level is always filled. Noble gases usually have 8 valence electrons on their outer shell, and that's how we represent valence electrons. All elements always want to try to reach this type of configuration, which is known as the octet rule, and octet stands for 8. So all elements are trying to have 8 electrons around it. If you look at this example, chlorine, this is an anion, all right, because remember anions are negative, and it doesn't meet the noble gas configuration, but it wants to gain 1 electron in order to get that octet, to get 8 electrons. So this element right now, if you count, it has 7 electrons around it, so it just needs 1 more in order to have that full 8 around it. If you look at neon, neon also meets the noble gas configuration because it has 8 electrons if you count around it. So neon is good, neon is stable. And then the last example is helium. All right, helium is a noble gas, but it doesn't follow the octet rule, so it's kind of just like an special element that's in group 18. All right, so what is ionic bonding? Ionic bonding has some type of characteristics. Ionic bonding always forms between a metal and a nonmetal. All right, it always has to be a cation joining with an anion. Remember, cations are positively charged and anions are negatively charged. And both of these atoms have to have opposite charges in order to bond. All right, if you look at this example, sodium with this 1 valence electron is bonding with chlorine that has 7, so chlorine just needs 1 more to fulfill that full octet around it. So ionic bonding occurs only when the number of electrons that are lost must equal the number of electrons that are gained. So sodium is losing 1 electron, but chlorine is gaining 1 electron, and that, if you count, equals 8. So this is considered an ionic bond. All right, this is just another chemistry picture of what ionic bonding is like. All right, so what are some steps in order to draw ionic compounds? First thing, you want to make sure that it's a metal and a nonmetal, and you can look that up on the periodic table. The second step is to draw the valence electrons for both elements, and if you remember in our previous video, we talked about how to identify different valence electrons using the periodic table. So we know potassium has 1, and fluorine has 2, 4, 6, 7 around it. So potassium is a metal, and fluorine is a nonmetal. The third step is to draw an arrow to show the electron transfer. So this electron is going to transfer over here. So potassium is going to lose an electron, but fluorine is going to gain an electron. And then here is just the images of that. And then the fourth step is to just draw the charges. So because potassium lost an electron, it becomes a positive, and then because fluorine gained an electron, it becomes negative. All right, and this compound that's made is joined by an ionic bond, and the compound is potassium fluoride, and it consists of potassium plus ions and fluorine negative ions. All right, and the ionic bond is attraction between a positively charged potassium and a negatively charged fluorine. So hopefully by the end of this video, a quick summary, we talked about different ionic bonds, and we talked about noble gas configuration and the octet rule. We understood how ionic bonds form, and we learned how to draw and show different ionic bonds. So I hope this video helped.